So today's topic is Class 8th CBSE Math Chapter 1 Rational Number. Before jumping to the rational number, there are 4 other types of number which we are going to know about. The first one is natural number. So what is natural number? I have shared in my previous video that it starts from 1. 1, 2, 3, 4 up to infinity is your natural number. Second one is whole number. Whole number means same natural number including 0. So if I write 0 and then as natural number, it will be whole number. There are representation of natural number. We represent natural number by capital N and whole number by capital W. Third one is integers. Integers are actually whole number, but it can be positive and negative both. Like if I take 0, then 1, 2, 3, and 4. We know they are whole number. But if move to less number than this, means with negative sign, that is -1, -2, and -3, and again up to -infinity is known as integers. Integers are represented by Q. The next number comes, which are rational number. So why we have studied these numbers in sequence and not started with directly rational number? The logic is, if I say all the natural numbers are whole number. See, every natural number are present into the whole number. But I can't say every whole number is natural number. Why? Because here I can see 0, which is not a natural number. Same way, if I say every whole number is integers, true, because in the integers I can see all these numbers which are whole number including 0. But reverse, like every integers is whole number, again not true, because negative number are not there into the whole number. Same way, rational numbers are those numbers which can be written in P by Q form, where P and Q are any integers. It can be any integers like -2, +2, anything. The only condition is the denominator, that is Q. It cannot be 0. So that is rational number. And again here, every integers are rational number, but reverse is not true. I'll give you one example. If I say 2 by 3, it is a rational number because it is in denominator form and denominator is not 0. Even -2 by 3 is in rational number. 2 is again rational number. Why? If you say there is a no denominator, it's okay because every number I can write with denominator 1. So the definition of rational number perfectly fit here, that is P by Q, and the denominator, that is Q, is not 0. So if I say all the number which is there in the integers, I can put 1 into the denominator and it is known as rational number. But reverse is not possible. Like 2 by 3, it has denominator 3, which cannot be written only by 2 or only 3, right? So the reverse is not processed. It is downward arrow is correct, but the upward is not true. So that is rational number. Here a little correction. Integers are represented by capital Z and the rational numbers are represented by capital Q. And here P and Q belongs to set. Means P and Q are integers. And sorry for this. Let's move to the next topic. Here we are going to study the 4 properties of all types of number. The 4 numbers we have studied: natural numbers, whole numbers, integers, and rational numbers. So first one is closure. Second one is commutativity. Third one is associativity. And the fourth one is distributivity. What are they? So let's first discuss the closure property. Closure property, if I talk for whole number, it means if I add two number, suppose 2 plus 3, which is 5. So if I add two whole number, again I'll get a whole number. Then I will say the whole number are close under addition. So take one more example. Suppose I'm taking natural number. If I take two natural number, let them 3 and 7. If I add them, what I get? 3 plus 7 is 10. 10 is again natural number. It means what? I will say natural number are close under addition. Take another number. Suppose again I'm taking 3 and 7, but this time I'm subtracting them. So 3 minus 7 is minus 4. 3 is natural number, 7 is natural number, but 4 is not a natural number. It is an integer. So I will say natural number is not close under subtraction. Means if something I'm doing, taking some time of numbers and doing addition, subtraction, multiplication, and division, whatever, if I will get the same type of number, then I will say it is close under that mathematical operator, else it is not. Take one more example. If I take integers, and I'm taking two integers, minus 3 and suppose 7. Here, if I add minus 3 plus 7, which is 4, and again 4 is integers, so I will say integers are close under addition. Take one more example. If I take 3 and then I subtract the second number, it is minus 10, which is again integers. So I will say integers are close under subtraction. Next operator, if I take multiplication, multiplies these two, 7 3s are 21 and minus 21 is again integers. So I will say integers are close under multiplication. Now move to the next operator, that is division. Minus 3 by 7 is minus 3 by 7, which will come in decimal. But decimals are not integers. So I will say integers are not close under division. So like that, we can study these properties for the other numbers. Moving to the next property, commutativity. Commute means moving. So take an example of whole number. Moving means what? If I add 2 plus 3 and 3 plus 2, they are same. So I will say the whole number are commutative under addition. 2 minus 3 is 3 minus 2. Are they equal? The answer is minus 1 and answer is 1. They are not equal. So I will say whole number is not commutative for subtraction. Same way, let's go for multiplication. If I say 2 into 3 and 3 into 2, they are same. So I will say both are 6 and 6. I will say whole number are commutative under multiplication. Now let's see the next operator, 2 by 3 and 3 by 2. This is 2 by 3 and this is 3 by 2, which is not at all equal. If they are not equal, so whole number are not commutative under division. We have studied two property. Let's do exercise based on this from the NCERT book. Look at this table. So we have studied the closure property. Here, I'm studying the closure property for different types of numbers. So first, rational number. If I add two rational number, do I get A rational number? Yes. So rational number are closed under addition. And yes, it is under subtraction. Let's check it. Check out multiplication. So if I take 2 into 3, correct? 2 number. If I multiply that, it is 6. And yes, it is a rational number. So they are closed under multiplication. Next, integers. If I add 2 integers, do I get an integers? Yes. Here, you can check it out. -3 and adding 6, both are integers. And I'm getting 3, which is again integers. Like that, you can check out for all the integers. And yes, they are close. Here for multiplication, if I multiply 2 integers, like take the same example, -3 into 6, what do I get? -18, which is again an integer. So again, it is yes. Coming to the whole number. Take any 2 whole number and add them. For change, let's take 0. So 0 plus 1, which is 1, again whole number. So yes, it is close under addition. Comes to subtraction. Take any of the number. Suppose I'm taking 3 and 6. Subtract them. It is -3. 6 minus 3 is 3. This is not whole number. This is whole number. So I cannot say in generalized term that the subtraction of 2 whole number is always an whole number, right? Because in this case, it is false. So even one case comes false, we will say it is not close under the subtraction. Whole number are not close under subtraction. Coming to the division, here also it won't come because 3 divided by 6 is 1 by 2. The reverse is means 6 divided by 3 is 2. But we are checking for all the conditions. Even one condition comes false, I will say no, it is not close. Coming to natural number. So it is again same as whole number. It is yes, no. Then multiplying 2 number, if 2 number is whole number, their multiplication will also be whole number. So, natural number, yes. And then again, no. So you can check these exercise. If you have some doubt, you can comment me. And I am promising I will definitely answer about it. Let's move to the second property, that is commutativity. Here, if I change the sequence, means if here addition and rational number, if I take 2 plus 3, the 2 rational number, even you can take in fraction because rational number are in fraction. Add them. So for adding fraction number, we need to take LCM. LCM of 1 and 3 is 3, making the denominator equal. Here I need to multiply it by 3. So 2 and 3 is a 9, which is 11 by 3. And yes, it is a rational number. So that is why it is yes. We have to check the reverse also. So 3 plus 2 by 3. Here, if I take LCM, again it is 3. And then making the denominator equal is 9 plus 2, which is 11 by 3. As it is coming same, I will say, yes, it is commutative. Rational number are commutative for addition. Let's go for the subtraction. So if I take these 2 number again, that is 2 by 3 and 3, and subtract that. So here, going through the same way, it is coming 2 minus 9 because only the plus sign has changed from plus to minus. It is coming -7 by 3. Sorry. And go for the reverse. That is 3 minus 2 by 3, which will come 9 minus 2 by 3, which is 7 by 3. We can say clearly they are not equal. So I will say rational number are not commutative for subtraction. Multiplication, yes, it is same. But for division, again, no. You can check it out by taking these examples one by one. For integers, addition is yes. Subtraction is no. Then multiplication, yes. And then division is no. Whole number, addition is yes. Subtraction, no. Multiplication, yes. And then division, definitely no. Natural number, Addition is yes. Subtraction, if I subtract two numbers, definitely natural number not necessary it will come. Multiplication, yes. Then division again, no. So if you say for all the numbers, it is approximately, not approximately, exactly same. The other two properties and remaining of the chapter will cover in next video. Take care and bye-bye. Keep studying. All the best.